Hi friends, my name is Apparao, working as Associate Professor in Computer Science and Engineering Department at Marri Laxman Reddy Institute of Technology and Management, Dundigal, Hyderabad, Telangana State. So in this lecture, I want to discuss about Ethernet topic. So Ethernet topic is available in Advanced Computer Networks course. So as I discussed in my previous video about course objectives, course outcomes, and unit 1, unit 2, unit 3, unit 4 up to unit 5. So in this session I want to cover Ethernet. In my previous session I discussed the data link protocol introduction, right? So now if you want to check my previous video, please kindly click on above link. Textbooks I referred, references. So in this session I have taken few content from tutorial point as well as geeks4geeks.organization. So now before going to discuss about Ethernet, what is an Ethernet in the computer networks I discuss. So what are the categories are available in the Ethernet and different standards available in the Ethernet. So now, so what is an Ethernet in the computer networks in the sense? Ethernet is, so there is a small introduction about the others. Ethernet is a LAN architecture developed by Xerox, as we know that, and extended by DEC, IC and Xerox. It is specified by IEEE 802.3 and it defines two categories. These categories are follows. First one is baseband, second one is broadband. So baseband uses digital signals, as we know that, while broadband uses analog signals. So these are the important terminology, especially in Ethernet: digital signals and analog signals. So baseband uses digital signals, whereas broadband uses analog signals. So baseband is further divided into five standard names for, as follows: 10 base 5, 10 base 2, 10 base T, 1 base 5 and 100 base T. So we'll discuss about these things. The first numbers used in all standards, that is 10, 1, 100. 100 indicates the data rate in Mbps, while the last numbers that is 5, 2, T indicates the maximum cable length or type of a cable. If you want to send a message, obviously we need some components, right? Like source, destination, media. So apart from that, we have a concept called Ethernet. So if it is a Ethernet 100%, so we have a different types of standard names. So these are the names. So first indicates data rate in Mbps, second numbers indicates length or type of a cable. So only one specification is defined for broadband. That is 10 band 36. 10 base 5 means a data rate of 10 Mbps and cable length restriction of 500 meters only. So this is the main difference for broadband and baseband. So these are the numbers I have given. The network uses, so if it is a network, uses carrier sense multiple access with collision detection, also called as CSMA CD technique for Ethernet. So when multiple users access a single line, suppose for example, so these are the source and this is the receiver. Also I want to add another receiver 1 and receiver 2. So now, so if you want to send a message, hi message from source to destination. So here there are two different types of users. So in that cases, the network uses carrier sense multiple access with collision detection technique. When multiple users access a single line, so if it is a single line, now see, so these are the different types of users. So now only one single line, only one line. So but multiple users, in that cases there is always a chance of overlapping and destroying data. So let's consider, so I have only one media. So in that media there are number of using the data. So in that cases sometimes overlapping and destroying data called collision. So if there any problem persists while transferring the data, sometimes we may lose the data or else we may damage the data. In that cases, the terminology called as collisions. Thus, if traffic increase on a single line, so obviously there are always chance of collision. The carrier sends several access with collision detection is a technique. So before that, before this ICMP, I discussed about CSMA CD, right? So apart from that, carrier sends several access with collision detection is a technique that can help detecting a collision. Suppose, for example, if we lost the data while transferring the data, so obviously then and there itself, so we have to resend the data. So which technique we may use for resending the data? So if it is multiple user access, a single line, so that is ICMP CD, carrier sends several access with collision detection technique, quits the current transmission and retransmission of data and takes place after waiting for predetermined time to get the line cleared. Now, electrical significations for Ethernet. So here, we have two different types of electrical significations for Ethernet, which as follows. First one is signaling, second one is data rate. Baseband system uses Manchester signals encoding, while the broadband system uses a differential PSK. We'll discuss. Next one is data rate. The Ethernet LANs supports a data rate between. So sometimes we may use LAN, sometimes we may use MAN. So sometimes we may use WAN based on requirement of the user. So in these cases, Ethernet LAN supports a data rate between 1 Mbps to 100 Mbps. Baseband defines 1, 10 and 100 Mbps data rates. So while broadband defines a data rate of 100 Mbps. So if it is a LAN, 1 Mbps to 100 Mbps. So whereas, if it is a baseband, so baseband data rate 100 Mbps. So this is the big difference. So here just I want to discuss about frame format. So IEEE 802.3 specifies only one type of frame format that includes 7 fields. These fields are as follows: preamble, start frame delimiter called SFD, destination address and source address, the next field length type, the PDU are 802.2 frames. Next, the last field is CRC. CRC plays a vital role in the computer networks. So now, preamble, it contains 7 bytes, 56 bits as we know that, and is used for synchronization. Next, starts frame delimiter, SFD. It is a 1 byte field and is used to signal frames beginning. So as we discussed, if it is a frame, so obviously, so there must be a one address for sender, so another address from the receiver. Based on that, so we can retransmit the data, resend the data. So if there any problem persist while transferring the data. Next, destination address and source address are fields are 6 bytes. So let's consider I have a frame format. So how many here? There are 8 fields. Now destination address and source address field are 6 bytes. Fields containing sender and receiver address is declared by the network interface card. So this is the example of frame format. 1, 2, 3, 4, 5, 6, 7 bytes. Now the next field length type. So length type is a 2 byte field and indicates the number of PDU we'll discuss and its type. It provides a base for other protocols. The PDU and 802 frames contains the entire frames as a modular removable unit. It can start from the 46th byte and can continue up to the 1500th byte. So we'll discuss. It is generated by the LLC sublayers depending on the size and type of the PDU, and then it is linked to an 802 frame. The last field is CRC, which contains error detection information. So now this is the frame format. We'll see with the graphical representation. The frame format is demonstrated in the figure. So now see preamble, SFD. So here 7 bytes, 1 byte. Destination address contains 6 bytes. Source address contains 6 bytes. Length of PDU. Next data and padding 802.2. Next 4 bytes CRC. So now in data padding, so we have a concept DSAP, will discuss SSAP, control and information. So MAC frame we can call it as. Now see token ring network, IEEE standard. This is in computer networks. In a token ring, a special bit pattern known as a token circulates around the ring when all the stations are idle. Suppose for example, for better understanding, so I have a source. So there is a station. So for sending and receiving purpose, if it is nearby stations receive the signals. Token ring is formed by the nodes connected in a ring format as shown in the diagram below. We'll discuss. Now see, the ring network is depicted in the figure given below. So this is ring network. So these are the tokens: system 1, system 2, system 3, system 4 and system 5. Now the principles used in the token ring network is that a token is circulating in the ring format, and which node grabs the token will have the right to transmit the data. A token ring networks, IEEE standard 802.5 in computer networks. Whenever a station wants to transmit a frame, suppose for example, a station wants to transmit a frame. So in this cases, one header format and one tail format, also called as address, single bit of 3 bytes token, which instantly changes it into a normal data packet, as there is only one token. There can be only one transmission at a time. Since the token rates in the ring, it is guaranteed that every node gets the token which are specified time. So hope you understanding. So there is an upper bound, and now see modes of operation in token ring network. So there are various modes of operations, so which are as follows: listen mode, talk or transmit mode, bypass mode. So now the main problem with a ring network is the network goes down when the ring cable breaks down or gets tampered. So while transmitting the data, so obviously, so breakage, handling of breakage, so into two categories, goes down. So when ring network is that the main problem with a ring network is that, so now token ring network, IEEE standard 802.5 in computer networks. In a token ring, a special bit pattern, so known as a token, circulates around the ring. So this one is the ring. So whenever you want to send the data, so obviously it circulates as in the ring format. So when all the stations are idle, so token ring is formed by the node connected in a ring format as shown in below, as we discussed earlier. Now the principle used in the token ring network is that a token is circulating in the ring. So now whenever a station wants to transmit a frame, so it inverts a single bit of the 3 bytes only, 3 bytes, which continuously changes into a normal data packet. Since the token rotates in the ring, it is guaranteed that every node gets the token within some specified time. So there is an upper bound on a time waiting for token, so that starvation is avoided. So there is also an upper bound limit of 250, so on the number of nodes in the token. Now token ring and wireless modes of operation in token ring network, so that is IEEE standard 802.5: listening mode, talk or transmit mode, bypass mode. So in the listen mode, the incoming bits are simply transmitted to the output line with no further action taken. If it is a talk or transmit mode, the ring interface is set to the talk or transmit mode. So when the station connected to the ring interface as acquired a token. Bypass mode, this mode reaches when the node is down. Any data is just bypassed. There is no 1-bit delay in the mode. Handling breakage. The main problem with a ring network is that the network goes down. So when the ring cable breaks down or gets tampered, the solution to this problem is the wire center. So in these cases, just I want to discuss one example. Suppose for example, I have a sender and a receiver. So in this, we have a transmission media. So while sending or else while transmitting the data in the form of frames, so obviously sometimes we may get some network goes down or else so we can tamper the data sometimes, right? So in that cases the use of a wire center, this wire center bypasses the terminals that have gone down from the ring. So this is done by connecting the bypass relay that station. Suppose we have to always take the backup of retransmitting the data. So in that cases, so in the network communication, in the advanced computer networks, we have a concept called as bypass relay for that stations. So these relays are generally controlled by the software that operates automatically. So if there are any data packets slows down or a network down, obviously your packets will be down, right? In that cases, the software is controlled automatically. So in case of station failure, sometimes station may failure, right? The use of a wire center improves the reliability and maintainability of the ring network. The main problem with a ring network is that network goes down when the ring cable breaks down or gets tampered. So now handling of breakage, by using this diagram we'll get the good knowledge about the handling of breakage. Suppose for example, so we have a wire centers, connectors, bypass relay, cable, station. Suppose I want to send one simple message. So obviously it's in the form of frames. So here, so I have a wire centers. So this is the wire centers. So as well as so we have some connectors. If it is a multi user situation, so in that cases we can send the data from directly or else we can take the data from bypass. So this is the cable, at the same time this is the station. So like that we have a bypass relay. So priority and reservation. So obviously, so for each and every frame, so we can give the priority and reservation. So IEEE 802, each station has a priority code. So now if you want to send your data, so if we assign some specific code, so obviously we can give the priority. As a token circulates on the ring, any station which wants to transmit the frame may reserve the token by entering its priority code, also called as access control field of the token frame by data time bonding. So if you assign a specific code, so that code gives a reservation for sending highest priority. So a station that is processes of token only can transmit is frame. So rest of the frames will be so delayed. So after this special frame is sent by the user, automatically gives the computer networks. So transmit one or more data frames, but before the expiry of token handling. So within the time period only, so the data will be transferred from source to destination. Token holding time. So suppose within the time period, so the frame should be sent from source to destination. So typically this time is 10 milliseconds. So after the THT, the token frame must be the monitor station. The monitor station sets the timer on when each time the token passes. So if the token does not regenerate in the allotted time, it is assumed to be lost. So within the time period, we enable to send the data. So obviously network within the time allotted, it is assumed that so your data is lost. And then the monitor stations generates a new token and sends it to the ring. So if the monitor fails, a second station is designated as a backup. So thank you for watching this video.